First of all, thanks a lot for Temporal for giving us the stage, and huge thanks to Temporal community. Otherwise, without the community help, we won't be here talking about that. So, Nash and I here to represent Maersk Engineering and tools and products and solutions we build internally. And it's not only me and Raj who build it, it's a larger group of engineers. So we're here to deliver the message, and all credits go to actual teams. Yeah. So, the time machine. Does anyone know why this machine is on the screen? Because we've seen people not knowing that already. And so for somebody who is trying to guess, it's not the Model X prototype. It's the actual time machine from the Back to the Future movie, and it was created specifically to travel through time. And what each time machine needs is, first, it's a machine. So in this case, it's the DeLorean, the only machine which was manufactured in Northern Ireland. Nothing else was manufactured since. Then this machine comes with the flux capacitor, which allows us to pierce through time, a special device. And also it runs on two types of fuel. One is the petrol, one is electric, which makes it a plug-in hybrid. And it also needed a tremendous source of energy. It's 1.21 gigawatts to be precise. And it has to accelerate to 88 miles an hour to travel through time. Fun fact that DeLorean could only accelerate to 85. So, yeah, strange things. Overall, we're here not to talk about the actual building this particular time machine, but would like to talk about engineering and how it helps to build solutions and product to manipulate time. And why time? So time is one of the most precious resources on our planet. You can never get time back. Once the time is spent, it is spent. You cannot buy it, you cannot get it, you cannot borrow it. And I've been watching the talk by Professor Scott Galloway, and he was talking about how to create a value when you're doing something, and especially how to create tremendous value by the company. And to create the tremendous value by the company, you actually need to focus on one and only one thing, is manipulating time. And you can either extend time or you can enhance it. And because we are a logistics company, we can only save time. We cannot make people to be friends or share social news by shipping containers, and that's what we do, right? We're saving time, and we're saving time for our customers because if you're a customer of Maersk, the last thing you want to do is to spend lots of time with user interface and clicking and flipping switches. You just like us to be very efficient, so and spend time in our system as less as possible and go about your business. And yeah. So, with all that, let's talk about Maersk. Right. What Maersk is a global shipping company, and with headquarters in Denmark. So it's I would say it's a European company, but we operate all over the world. It's probably about 30% things you see and carry and own was once on our vessels or containers. And we've been in business for over 100 years, and it's a lot. So we carry a lot of legacy, a lot of experience in the industry. And if you look at the supply chain, it's not that simple to deliver things from A to B. It's quite complex. It involves lots of people interacting, lots of documents, lots of custom clearances, paper exchanges, lots of places where your cargo can be. It's a terminal, it can be in a vessel, it can be in warehouses and factories, etc. So, and during all this journey, there can be delays, unexpected delays, and these delays can be due to the wrong documentation, it can be due to some weather conditions or due to some country restrictions, and all these elements, they contribute to overall delivery time, and it won't be pleasant if we made a mistake, for instance, on the booking phase and then didn't have enough documents to present it for the customs. So before that, it's quite complex process. It's not easy to do, and we've been doing it for quite a while, and we're here, right? So, for instance, let's take a simple case. We have a store owner or business owner who doesn't have enough hours in a day, and he would really like to get an apple delivered from far away to his store so he could sell it to somebody. And I'm talking about the real apple. And so this customer, he doesn't want to spend hours and hours in arranging the booking and paying for that and doing all these things in our system. So we need to make it as efficiently as possible. And so in order to make this delivery, I would just simplify it. So customer would like to go to the portal and submit all the documentation, choose the shipping plan according to the price preferences, and then pay for that. And documentation, collection, shipping, and payment, it's quite, again, a bit complicated process. So and once we have the payment received, so we will ship these goods, and the customer will receive notifications and can monitor this delivery, etc. So, but it still takes a lot of time right now, and it may be frustrating for a customer to spend that much time in the system. So, our business, for instance, had an idea, right? An idea about the application to improve the life of this customer, how to make things faster, easier, and more efficient. So, if I'm a business, let's imagine I'm coming to our development team and asking our favorite developer, Raj, how long will it take to deliver the application I have imagined?
So this is the question, right, which often crosses the minds of the developers, and it is the one which doesn't come with an easy answer. Just to put it simply, right, it will take a significant amount of time. You see, most of the time that we spend today, right, is to manage the operational readiness rather than crafting our core business logic. So what you see on the screen, right, is some of the challenges that we face as a development team. So the one on the left is the challenges, and the right is the relative time it takes to accomplish these challenges. So you can take as being maybe a sprint, or you can take it as a shirt size, right, and you can, as and when you go up, it more the time it takes. So let me talk about some of the challenges, right, what we face today. The very first challenge is data consistency. So Maersk, as you said, is a kind of global company. It operates in the different time zones. So this mandates our application needs to be highly resilient and available around the clock. So to have the data consistency in place, we need to create a state machine. And I'm very much, I guess you know, right, how much difficult it is when it comes to building a state machine. So this state machine requires a database. And again, right, when you have a database in place, there are a lot of complexities which are being added to your application. So now since we add a state machine, right, your normal code, let's say your 5 lines of code will now become 15 lines of code. So once you make a changes to your code, your maybe around 5 test cases will become 15 test cases. So then, right, since you need to manage your application as well as your state machine, then you go into the complexities of deployment and scaling changes. If you follow this pattern closely, right, so this kind of creates a domino effect, wherein if you introduce changes in one place, it has a kind of impact on the outcome of the other changes, and this kind of takes a lot of amount of time. The second challenge, I would say, is the need of caching layer. And I guess everyone knows, right, caching is required when it comes to optimizing the performance of your application. But yet, right, setting a cache is not an easy task. And again, you get into the same complexities which we just discussed, right, creating a database, creating a caching cluster and all. The third challenge, I would say, will be kind of a need of application RBAC. Because application RBAC is anyways needed because we want to ensure that our services are highly secured. Now, to create this RBAC, right, first you need to get into complexity of creating roles. And then if you are at the source system, then you need to kind of create a JOT token, write a separate code for that. And if you are at the receiving end, then you need to again kind of have some packages wherein you authorize this token and so, stuff like that. The fourth challenge would be like an inter-service communication. So as you know, right, Maersk has the services deployed in different regions in cloud. So like maybe some are running in Japan, some are running in US, and some are running in Europe as well. And some of the systems, right, are also running in the data center. So if you want to have a seamless communication and a secure communication between the services, you need to do some tweakings to your network configurations. And sometimes this requires security clearance. And you know, right, how nasty it is when it comes to getting a security clearance, because it's very difficult. It takes a lot of time to convince them. And if you do convince them, then you need to again kind of get some approvals from your higher ups just to make those network changes. And this takes a lot of amount of time. Finally, right, the final piece of puzzle would be a production readiness. So this is when you will be kind of deploying your application to a cloud, right? To do this, today what we need to do is we need to kind of get into the complexities of creating CI/CD pipelines. Then you need to create a container registry, push your Docker images to that container registry. Then you need to create some Kubernetes resource manifest. And to do this, you need to raise a couple of fancy PRs. And again, you get into the same problem of review commands, and you need some approvals and endless discussion, and this basically takes a lot of amount of time. So just to answer to your question, right, how long will it take? So if you ask me, since we do not have a time travel machine today, I would say it will take around 60 to 80 days of time to accomplish this task. But if you see, right, it is not just the amount of the code that we write, right? It is about the time that we spend on this non-business critical activities that ultimately determines the time. I hope that answers your question.
Yeah, thanks, Dhanraj. So I'm going to reach for my wallet, right? I have some money. Can you hire 6 developers and make it faster?
No, I don't think so, right? Because see, in fact, it will take more time, because now you need to hire these people, you need to upskill them, and this basically takes a lot of time. And the problem is not the people working in the product, right? It is about the time that we spend on non-critical business activities, and for that, there is no solution.
All right, thank you. So basically there is a problem, and the problem cannot be solved by throwing more human or people in the pit. So we can only solve the problem by technology, because that's the issue we have, right? And what we needed is a solution which allows us to travel through time. And we needed this flux capacitor, and this flux capacitor also needed a power source, and the power source which will give us exactly 1.21 gigawatts of power. You probably may have a good guess which the power source we use to drive our flux capacitor, but we will talk about that in a while. I want to quickly introduce these platforms and why we had it and the reasonings behind having those on the first place. So let's start with developer platform. So the first problem we had is we had these diverse developer experiences, and we wanted to unify them. So the developer platform provides an option for developers to log in and in 5 minutes receive the production-ready application with the endpoint. Well, it will probably not be a very useful application, but in 5 minutes you can have it. Then these developed platform orchestrate other platform capabilities to actually build something useful and produce the application stack required for this application to run. So it serves as a top-level orchestration for our other platforms. The other platform we use is the service mesh. So for service mesh, we had a few challenges because we wanted to do the AB canary and route traffic, do circuit breakers, so all kind of stuff for the internal services. And especially we have the challenge where we have some services in the cloud or across multiple data centers, and we wanted to enable connectivity in a very seamless way for developers, just through the configuration. We had the service composition. It manages the data consistency across multiple services, just straight out of the door, so it uses Temporal. And we have the application airbag, and we needed to come up with this module because we didn't want our developers to re-implement this airbag feature for the business users to be able to assign some grants and roles, etc. So we added this module as a platform, so which developers can embed into their applications. We do have the APIs gateway. This is our third iteration, and hopefully it will be the last one because we are building the control planes for the gateways and for managing this API lifecycle. So it allows developers to quickly publish secure API, which doesn't need to have another round of security reviews altogether. Well, we do have the UI framework, which is not kind of part of the backend subject, but we figured that developers also spending lots of time kind of re-implementing certain components, plus some of our platforms, they needed direct user interface component integrations, so we created these frameworks and which can be put together into the nice UI quite fast. We do have secret management. So secret management is not a big time differentiator for us, but it is super annoying because our application can talk to multiple backends and can be databases, can be storage accounts, can be other endpoints, and these secrets, they regularly rotate, so it's a responsibility of the application team or product teams to make sure that they update all the secrets in the applications, and it's not super convenient to have this kind of thing. It's really annoying. So we came up with the single identity design where application comes with the single identity and then it fetches all the secrets, where the secrets are rotated by actual platforms who provides the service, but platform can only write and application can only read. We have cached data services. That's for the application caching, and it's started as a simple application caching. Now we want to make it kind of event to API pipeline, so developers, as again we often see, have a requirement to make the data readable as an API, but data comes as an event stream, so we have it like that. And finally, we have a decision automation, and because of the nature of our business, we're a logistics industry, there's lots of rules and regulations which we have to deal with. So we kind of put it together into the platform world. And again, MBNO module. So with all that, we can accelerate to 80 miles an hour and ask the question again. The nudge, how long will it take?
Wow, Andre, right? Like, you truly built some mind-bending tech here. It feels like I just hopped into some time machine, to be very honest. Right? You kind of provided solutions to all the problems which I just discussed previously. And now the experience is super seamless. You can actually see the smile, right? Bright smile on my colleague's face here. That explains you everything. I need not explain more. Okay. So the first product, right, which you said is service composition. So that solves the problem of data consistency for us. So we now can create a complex and resilient application just like that, and it saves a lot of time, because now the service composition gives me everything, right, which is needed to create a state machine out of the box. Then the second thing is the cache data service. So now this service creates your caching layer in a very straightforward process. And with few clicks of buttons, I can get my cache platform ready and ready to roll, just like that. The third thing is the application RBAC. So this truly simplifies the way we create role authorization. And did I tell you about the application packages that you ship with that? So that is been a complete game changer for us. The fourth thing is the service mesh, which kind of simplifies the way we do the inter-service communication. So now, right, it is very easy and it is very secure to make service calls to our DCs and to our different clouds. It has been a very good experience. The last and the final icing on the cake would be a developer platform. So this is like a complete magic. I guess within some click of buttons, I can get my initial application along with CI/CD pipelines and GitHub repository and I would say container registry and the cloud deployment out of the box. So how cool is that? So because of this, right, this developer platform, now we can save a lot of amount of time, and we don't have to get into the complexity of the Kubernetes platform. So that's been a real game changer. So if you ask me the same question again, so how long will it take? So since you kind of simplified everything, right, for us, I would say on an average, I would now take around 5 to 10 days to get the same job done. But hang on, I'm kind of curious to know, I guess everyone else also, right? What is the secret recipe behind this your time travel machine?
Okay, let's talk about that. So with all the work paid off and contributions from all the engineering teams in Maersk, we finally got it. But we're still getting bits and pieces together. But let's talk about our secret ingredient, right? So our secret ingredient, as no surprise, is Temporal, because it actually enabled our development, or say, engineering teams, who are developers as well, to build control planes for the platforms, to build different solutions, and they found it super easy to get started and build these solutions with Temporal. It gives them the power to do it. And what we found is, we found few common patterns which we use, or which our teams use, while we're building the solutions. So let's walk through those, right? The first one is a job schedule pattern, and it is exactly that. So it does something on a schedule. For instance, for service mesh, we reconcile our service ownership information from different sources to make sure that we have up-to-date information, but you can apply it for anything. And the good thing is it can also run in distributed jobs, so you can run jobs in different regions, different zones, as long as it can connect back to Temporal server. We have the infra-broker pattern. An infra-broker is one of the most frequent, and you can call it a control plane, you can call it the infra-broker, and for instance, it's used by a development platform team or development platform to assemble the service provisioning across all the different platforms and put them together into the application stack. And in our data services or data cache services, we use infra-broker to create caches across different clusters, spread across different zones. And there are many use cases like that, so we're still exploring and implementing those. Then there is a development pipeline, and so it replaces the GitHub Action deployments and for us. And again, our development platform uses the development or deployment pipeline to deploy the application into multiple clusters and configure all the endpoints and routes which is required for this application to work. And for our decisioning service, we again use deployment pipeline where we deploy these bundled decision executables collocated with the application stack as well. It's all good. It's all working well for us, and now our engineering team is on steroids. Like, it's all pumped up and saving lots of time. It's very efficient, and our teams love it. But let's talk about the business. What actually happened after we got these wonderful technologies enabled for our developers? So you can see the Apple finally arrived, and the guy, this shop owner, is super happy, super relaxed, and he have much better experience of our systems now. So let us share what we actually did for the business, and I will hand over to Denraj to talk about that.
Okay, all right. So since now our tech is supercharged, right, thanks to Temporal. So now let's see how we leverage Temporal when it comes to solving our day-to-day business problems. So we're going to discuss two use cases here today. So one is the payment flow, and the second is the booking flow. So as usual, right, I'll start with the problems that we face today and the way we solve the problem. Okay. The very first use case is the payment flow. I guess every company, right, which uses Temporal has the payment flow as a use case, and so we are no different exception here. So we have the same use case as well. Okay, so for the payment flow, right, the flow is something like this. So the moment user submits a payment request, it sets off the sequence of events. The payment orchestrator kicks off by sending an event to the external payment gateway, and then the payment gateway sends you a response with the success. Right? Let's talk about the happy use case. So once we get a success response from the payment gateway, we then proceed to update our underlying systems, which is the booking service, because we now need to update the booking service that we have received the payment. The second service is an account service, which is basically kind of bookkeeping service for us. And third is a notification service, which is kind of sending a notification to the user, as simple as that. So far, so good, but this is where the trouble begins. So what if, right, one of our application, the downstream applications, fails? Let's take an example of account service going down. That could be any reason. It could be underlying networking issue, or it could be code issue, or it could be anything. So let's say the system went down. So when this happens, right, from the payment orchestrator, we give a error response back to the payment gateway. And we rely on the payment gateway to do the retries for us. You actually heard it right. We rely on the payment gateway to do a retry for us. That's not a good thing, right? That's not a good design decision, because it should be other way around. We should be the one who should be owning the retries. But now you might be wondering, right, why this is the case. So this is because your payment orchestrator is a stateless service, and it therefore lacks the ability to manage the retry on its own. So a second problem right here is since we wait for the payment gateway to do the retries for us, so payment gateway does the retry as an exponential retry. It doesn't retry very frequently. So let's say, right, it made a first call. The second call, if you do not recover within that time, the second call would be in minutes. And maybe if you do not still recover, then it will be in hours, and it can also go to till days. And this, right, kind of creates a lot of delays at the shipping side. The next thing, right, when the payment orchestrator does the retry for us, what we do is we kind of redo all the services all over again. Let's say in this case, right, it was an issue with the account service, but since at the retry, we again redo the booking service and other services which were actually working fine before. So that's again the problem. We redo the things again and again. Now, because of these issues, right, and since we do not have the confirmation of the payment yet, we do not release customers' cargo. And as you know, right, this is kind of frustrating experience to our customers because this adds to the delay in the shipments, right? So what does our customer do? So they basically reach out to our customer care agents. And the life is not easy for our agents as well, because since the application lacks the ability, right, to check the payment status, the agent has to do a tedious task of going to each and every payment gateway manually and checking the status, and then they need to manually release the cargo. So obviously, right, this is not the kind of experience that we want to give to our customer as well as to our dedicated agents. So how do we solve this problem? The naive approach would be to kind of infuse the state into the payment orchestrator. We do this by adding a database and kind of use a scheduler, right, just to retry or something like that. But as you know, right, adding infra resources, adding a state machine is not an easy task, and it kind of has adds more complexities. Is there a smart way, right, by which we can solve this problem? Let's find out. I guess by now you might have already guessed, right, how to solve this problem. So what we've done now is we've kind of introduced a temporal workflow to our payment orchestrator. So our payment orchestrator becomes a workflow, and our booking, account, and notification services become an activity for us. So all we had to do, right, was to create a simple interfaces for workflows and activities, because most of the code was already there. So we had to just create an activities and just kind of arrange the code as per how the temporal needs it. Now, because we add the temporal to this application, now we got the state machine out of the box, and also, right, we have automatic retries in the place. Since we have this in place, we do not really now rely on the payment gateway to manage the retry for us. So now the new flow is almost same. So the moment, let's say, we make a call to payment gateway, we get a response from the payment gateway, and we immediately give the response back to the payment gateway that we have received confirmation from the payment gateway. So after that, what we do is we update our booking service so that we can release the customer's cargo immediately. And this has considerably reduced the wait times, right, which we saw in the previous cases. And then we start making the parallel calls to our account and notification service, and this basically completes the workflow. If you see this, right, the addition of temporal has really helped us. So now our payment process is very super smooth, it is highly resilient, and it has also reduced the customer's wait time. Now let's talk about the second use case which we have. So this is a case of the booking flow. So from its origin as a prominent shipping company, right, now Maersk has become a global leader into integrated logistics. So we have kind of expanded our horizons by venturing into inland shipping, then air cargo, then supply chain management, and warehouse and distribution, customs, right? These are the various offerings that we do provide now. So what you see on the screen is our 2-decade-old legacy booking application. This is a very huge monolith, and now currently this supports only our booking, like ocean bookings. So the problem here, right, since it's a monolith application, right, it gives us very little improvement to do more modifications to this code. And as a result, what we ended up doing was we ended up creating a multiple parallel order management application to kind of cater to our other business logics, right? So that's the problem. And there is this saying, right, they say if you have a legacy application running in your background, you shouldn't touch it, because who knows, you might break what. So we ended up creating a multiple parallel the order management applications to suffice our new needs. The second problem is, since it's a monolith application, it has the same challenges which is associated with any normal monolith application. So we share the same database across the entire application. Like this application is tightly coupled, as you can see, and again, right, it doesn't have the kind of complete end-to-end visibility. So let me talk about this end-to-end visibility. What is the problem here? If you see this application, right, it kind of interacts with the multiple touch points. So right from you create a booking, booking, then you load something to the truck, then you put it to vessel, then you have customs, and finally you deliver the product, right? So if you look at this, right, so there are this has different interactions, and what we have is we use a choreography pattern just to get these updates from the different integrations, and as you know, right, choreography, it is very difficult to understand. So in a given point of time, it is very difficult for the developers as well as our business people to know what is the progress of the booking at a given point in time. To get this information, what we do currently is we kind of manually check the status of the different applications which we have in place, which is not a really good idea. Now think about this, right? Let's say we get into some production incidents and we get into the call, and all we do is just to spend like lot of amount of time just to identify which system has the problem, rather than actually providing the root cause of that, right? So this is the problem which we have. So what are the solutions, right? What we want to kind of achieve out of this? So we want to create a single order management application that caters to all our booking applications, be it inland, be it air cargo, be anything. We want this new application to be highly resilient, obviously, because we operate in different time zones, so we need our application to be highly resilient. And obviously, then this application should react to the external events, because as you can see, right, we have so many external events. So if I had to kind of do the transformation of this huge application today, right, it will take us, I guess, few years to complete this transformation. But here's the interesting part, right? We have Temporal, we have a time travel track here, so that actually simplifies the way we do the transformation. So that's the tagline, right? Nothing to fear, I guess, just like that. Okay. So this is how our new booking flow looks like, and this is completely being powered using a Temporal workflows. So what you see here is like a very high level overview of the workflow, and I don't want to get into details because it's too complex and it is beyond the scope of this discussion what we're having now. So what we do right here is each block that you see, right, is like a huge microservices, and it's a big like a kind of domain team within the Maersk. So what we want to illustrate here is how we use a Temporal workflow to kind of stitch the different domains within Maersk to give us a unified booking experience. So the flow is something like this. So the moment user submits a booking request, our Temporal workflow springs into action. So it kicks off by kind of creating a booking metadata. So this basically, booking metadata, you can think of any information related to booking. Could be like your source information, your destination, what kind of goods that you are kind of shipping. It could be like a perishable goods, maybe fragile goods, right? So all those booking related metadata is being captured by this activity. So once we have the booking activity, right, we then venture into the planning phase, and this is where, right, we kind of do some forecasting checks or inventory checks before we even start the journey. The third phase is a confirmation phase, and as the name suggests, right, we just send a kind of confirmation to the customer saying that this booking is ready to be shipped. And also at this point of time, right, we do allow a customer to make any amendments to the booking. So we do so by just adding a temporal timer there, and it has some kind of grace period during which customer is allowed to do the modifications. So if there are any modifications, right, we do it simply by issuing a signal to the workflow to get the new booking details. And if there are no modification, then obviously your timer expires, and then we go to the next phase, which is the execution phase. So depending on each of the offerings, right, that you select, could be, let's say, air, or could be inland, or could be customs, right, we have a child workflow, and this child workflow is a huge kind of business logic and has its own independent logic. So let's take an example of one of them, right? Let's say you want to do international shipping, and you opt for Maersk Custom Service as one of the add-on package. So you know, right, when it comes to international shipping, there is a customs involved at two places. One is at the source and one is at the destination. And to have this custom clearance, right, you need to submit some documents. So let's say just to get the customs cleared, you need to provide some documents. And so this child workflow, right, at the execution phase, it gives you the ability to upload your documents. And so how do we do this? We basically kind of issue a signal to the workflow. And it also provides you an ability to check the status of your custom clearance at the real time. And for this, we basically use a query to the workflow. So once my execution phase is complete, then we go into the billing and invoice phase. So, and this is where, right, Temporal's dynamic workflow nature really shines. You see, right, so billing, and so we have kind of two kind of bookings within Maersk. So one is something called instant booking, in which case your billing and invoice comes before the execution phase. And the second line of booking is the credit line bookings, wherein we send the invoices at the end of the booking. So we do not have a kind of static workflow here. So we have a dynamic workflow. So during the runtime, we decide whether the billing should be before execution or it is after execution. So that is where this really comes handy, the dynamic nature of the workflows. So once your payment is done, then you start sailing to the destination address, and once it reaches the destination address, right, we basically send a signal to the workflow saying now the complete booking journey is complete, and that marks the end of the booking. So if you look at this, right, so let's answer this question: what Temporal brings to the table for this complex application? The first thing is our workflows are like complete dynamic. As you can see, at the runtime we decide like what activities to like invoke before or after. The second thing is we have a long running workflow, because obvious, right, you cannot transfer goods from one country to other country in like minutes, right? It can take around a few days, and even it can take few weeks also. So the workflow is completely long running, and we then get this state machine out of the box. So we don't have to again spend time into building complex state machine. The third thing is we now do not, we completely use the Temporal's own native task queues for the inter-service communication between the different child workflows and the activities. So before we were using kind of MQs, but now we are not. We are using the Temporal provided task queues. And the final advantage that we see is the complete end-to-end visibility, because now, right, since we have an orchestrator in place, it's easy for us. We can go to Temporal UI, which is very elegant UI. We can, at the real time, we can see what is the progress, what is happening with the booking. And if there is an issue, right, it is very easy to now pinpoint and provide a fix for that. So this is all about the booking flow, and this is not the only use case, right? So we have like other use cases as well. So something called as a contract negotiation service, then providing end-to-end visibility over to our customers, right? And so something like that. So if you look at this, right, so it speaks the volume of the level of confidence that we have in Temporal when it comes to our business use case. And if someone asks us, right, so what is your use case with Temporal? I guess we'll say we have like many use cases, so something like that. So with that being said, let me hand it over to Andre for, yeah,
yes,
thank you.
Thanks, Dharaj. Awesome. So now is the time to answer the question, is the time travel possible? Well, according to the relativity theory of Einstein, it is. If you go really, really fast, then time will slow down for you compared to the one who is not going really, really fast, right? So in this case, we're giving time back compared to our old selves. And we're giving a lot of time to our customers, we're giving a lot of time to our engineers to do better things with their lives, connect with their families, invest in businesses, invest in personal trainings, everything. And it is all possible due to this special fuel, which is Temporal. So thanks a lot.
All right, I think we have time for probably one question before we need to move to our final talk of the day. Oh, here you go.
Hey, so you show that in your deployment pipelines, you shifted from GitHub Actions to Temporal. So can you talk about what motivated the change to go to Temporal?
It motivated us the flexibility of Temporal because we wanted to be in multi-cloud and multi-cluster, and we can also deploy to the on-prem environments. And with GitHub Actions, it's just simply inconsistent experience because you either have to deploy these GitHub workers in every location, which is not quite good. Then you deploy GitHub workers to these locations, you don't have visibility because it either fails or not fails. And there is no basically option to retry it in a way we wanted to be retried. So it's all flexibility, which Temporal gives us.
All right. Well, thank you very much. It's fantastic.
Thank you.